There is no evidence of truss bridges in the ancient world, but the 30th century sketchbook of the French architect Villiers de Honnecourt depicts pieces of truss bridge. So, have you ever wondered why there were truss bridges? What types they exactly? How are they built? Are there types of truss bridges out there? How are they able to withstand the tension and compression? This is Statics 101, and here's an overall view about truss bridges.
Before Industrial Revolution, almost all bridges in use were made of stone, but when the United States realized that wood and iron can resist tension and compression better than stone, they started creating wooden truss bridges, until metal slowly replaced wood and wrought iron bridges started appearing. In truss bridges, you may notice the triangular shapes in its construction, and you may wonder why the triangular shape is included here. If you think that it is only for design, then you are wrong. Triangular shape is also called a truss, and if the truss becomes a component of a load-bearing superstructure, such as bridge, it is also called a truss bridge. Truss bridges are one of the oldest types of modern bridges, and a truss bridge may carry its deck on top or at the bottom of the truss, and they are accordingly classified into deck truss or through truss.
Truss bridge is made by joining beams and truss members such as chord, verticals, and diagonals. Generally, if the elements span too much, it will bend while forces act on it. This is called the bending moment. Truss is used to avoid the bending moment and to maintain stabilization. The force will try to bend the bridge if it was constructed with square element, causing it to break. But if it has a triangular element, the external force will distribute through the element equally. As you can see in the figure, the vertical truss received the tension, while the diagonal truss received the compression. They are constructed consecutively so that the forces are distributed equally. Although, this can be inverted depending on the type of truss bridge, but the purpose is still the same.
Here are some common types and examples of truss bridges. The hoe truss bridge. Here, the diagonal structure beam slope towards the bridge center. This approach makes diagonal members of hoe truss bridge in compression, while vertical web members are in tension. An example of this bridge is the J Bridge in New York, which is a wooden bridge that spans along the east branch of the Oswego River. Another is the West Ham Island Bridge, which is partially a single-lane wood deck truss bridge located in Colombia. The Pratt Truss Bridge. This includes triangular truss design whose diagonal members slope towards the center of the bridge. When under load, this design makes diagonal members feel tension while vertical members feel suspension. An example of this is the Fair Oak Bridge in California, which is a truss bridge over the lower banks of the American River. The Warren Truss Bridge, it consists of equilateral triangles. It spreads tension and compression very evenly. Example is the Sewickley Bridge, a still continuous truss bridge spanning the Ohio River.
The K-truss bridge, it is named after the cape formed in each panel by the vertical member and the two oblique members. A Parker truss bridge, it is a Pratt truss designed with a polygonal upper chord where the upper chord consists of exactly 5 segments. This is Statics 101, and here's an overall view about truss bridges.